we've done so far when we have gotten the square root by itself have resulted in a linear equation? Well, sometimes when we do this, we're going to end up with a quadratic equation. And we know that with quadratic equations, a lot of times we end up with two solutions, and it's very important when you have two solutions that you check both solutions, because sometimes both of them will work, sometimes one of them will not work, and then sometimes neither one of them will work. So it's very important, especially when you have quadratic equation that you're solving, that you check all your solutions after you've done it, okay? So with this first example, we've got n is equal to the square root of 12n. So the square root's already isolated. Our first step is to square both sides. So when we do that, we end up with n squared is equal to 12n. Now, anytime you've got the variable squared and just a plain linear form of that variable, your equation has to be equal to 0. Okay, we can't just divide both sides of this by n. We will lose one of our solutions. So that means we need to subtract 12n from both sides. So we get n squared minus 12n is equal to 0. To factor this, we have a GCF of n. So we've got n times n minus 12 is equal to 0. So that says one of our solutions is n equals 0. The other solution is n equals 12 if we add the 12 to the other side. Like I said, it's very important to go back and check both of those, plug it back into the original. So if we plug in 0, we get 0 is equal to the square root of 12 times 0. Obviously that's true. And then if we plug in 12, 12 is also true, because 12 and 12 is 144, square root of 144 is 12. So both of these solutions check out for this equation. Okay. Let's look at example B. We have the square root of 10 minus 3m is equal to m. Again, the square root's already isolated, so all we have to do is square both sides. So when we do that, we get 10 minus 3m is equal to m squared. Again, this is a quadratic equation, so it must be equal to 0 in order to solve. So we need to add 3m to both sides and subtract the 10. So we get 0 is equal to m squared plus 3m minus 10. It's very important that you're careful with your signs, because y'all know anytime factoring is involved, if one of your signs is wrong, it can throw off your entire answer. So when you factor this, it's m plus 5 times m minus 2. So that means we get negative 5 and positive 2 as answers. When we plug in negative 5, we get 10 plus 15, which is 25. The square root of 25 is 5, but this says that it's equal to negative 5. So we've got to throw out the solution of negative 5. Okay. When we plug in 2, we're okay, because we got 10 minus 6, which is 4. Square root of 4 is positive 2. So m equals 2 is the only solution for this one. Okay. Don't forget that you can always solve by graphing. So if you're kind of having that question of, well, do I really throw out this answer? Remember, you can always plug in the left side and in y1 and the right side in y2. And what are you looking for? What do we look for on the graph for a solution? Where they cross, where they intersect. And so you can clearly see that these only intersect in one place. They don't intersect in 2 places. Okay, so just keep that in mind. You can always solve by graphing or check by graphing. Okay, let's look at C. We got a little bit more going on with C. We've got negative 2 is equal to negative b plus the square root of 4b minus 11. So this time, the square root is not already isolated. It is not on a side by itself. So our first step is not to square both sides, but our first step is to get that square root by itself. So in this case, we're going to add the b. So we've got b minus 2 is equal to the square root of 4b minus 11. Now it's by itself. We can square both sides. But we've got to be careful with this. The left side is not b squared minus 4. Okay? We've got to FOIL that out. It's b minus 2 times b minus 2, which is b squared minus 4b plus 4 when we FOIL that out. And that's equal to 4b minus 11. Still a quadratic equation, so everything needs to be on, in this case, the left side. So we subtract 4b. Be careful, those don't cancel. They're both negative, so they just combine. And then add the 11. So we get b squared minus 8b plus 15 is equal to 0. So we've got b minus 5 times b minus 3. So positive 5 and positive 3 are solutions. Check them. 4 times 5 is 20. 20 minus 11 is 9. The square root of 9 is 3. So negative 5 plus 3 is negative 2. So that one checks out. Plug in 3. 4 times 3 is 12. 12 minus 11 is 1. Square root of 1 is 1. So negative 3 plus 1 is negative 2. So in this case, both solutions check out. You can, of course, check them in the calculator. I'm just getting a little mental math practice going on, which would be good for you to do. Hint, hint. Okay, let's look at D. Okay, similar to the one that we just did, but it's already isolated. Okay, the square root is already isolated. The square root of 8 minus 8b is equal to b minus 3. So we can jump to squaring both sides. And again, b minus 3 squared is b minus 3 times b minus 3, which when we FOIL that is b squared minus 6b plus 9. So in this case, we're going to move everything to the right side. So we add 8b and we subtract 8. So we get 0 is equal to b squared plus 2b plus 1, which factors, that is a perfect square trinomial, factors into b plus 1 times b plus 1. So we get b equals negative 1 for a solution. But let's check it. 8 minus 8 times negative 1 is 8 plus 8, which is 16. The square root of 16 is 4. When we plug it into the right side, we get negative 4. So this one has no solution. Okay, this one has no solution. Let's look at it really quickly on the graph, just to confirm. Anytime you get no solution, I'm always a little wary. I'm a little afraid that maybe I've overlooked something, so I always like to check it by graphing, just to guarantee that my graphs do not intersect, and they don't. Okay, the square root function really does stop right there on the x-axis, so it never intersects with that line. Okay, so no solution on that one. That is a possibility. Okay, we can have 2, we can have 1, we can have none. So you always want to check. Always want to check those. Okay. So here's some practice.